Okay, now we're ready to start our lesson. And this is section 6.2 again. And these are curves that do not cooperate like my students don't cooperate. And you'll get what I mean in a minute. They don't cooperate. They sort of do what you want them to do, but not exactly because they find their own way. That's my students. All right. What if you are given... Huh?
Curves like Jacob.
Yeah. What if you are given that f of x is equal to x minus 1 and g of x is equal to the square root of 3 minus x and h of x is equal to the negative square root of 3 minus x, and you're asked to find the area between those three curves? What are you going to do? Well, for starters, if you remember anything from Algebra 2, which would be really handy if you did, if you remembered Algebra 2, you would recognize that these are two arms of a parabola, a sideways parabola. It's the positive arm and the negative arm, right?
Yep.
So when we go to so you need to sketch it. You have two ways. I can sketch it either way. I can sketch it just using those, or I could change these two to a parabola and sketch it a sideways parabola. Which would you prefer? Do you care?
Yeah. Can we do both?
We can do both. Okay, so if I'm doing it just using the x's, what I'll do is I'll make a table over here. So I have y equals x minus 1. So I'll find the coordinates for it to graph, right? And so I should find the points of intersection first. But it's so much easier to do the sideways points of intersection because they're not what you expect. There's 3 of them. Look, can I do the sideways one first and show you? Because it'll be much easier if we do the sideways one. So if I do sideways, what I do is I take this, I take these curves, and I realize that that's a parabola, right? Because that's y equal to the positive and negative. So if I square both sides, I get y squared equals 3 minus x. And if I solve for x, x is equal to 3 minus y squared. It is a sideways parabola that has a vertex at the 3, 0, and it opens to the left, right? Correct? Opens to the left. Like this. Actually, this is for y'all right there, like that, right? And what I'm going to do is I'm going to solve this one. This is y equal to x minus 1. I'm going to solve it for y also, for x also. So what I'm going to do is for the first curve, it's going to be x is equal to y plus 1. And for this one, it's going to be the x equals 3 minus y squared. So I got to find the points of intersection. So I set them equal to each other. I now have y plus 1 equals 3 minus y squared. And I'm going to erase this and I'll do it down below. So I move everything to the left. To the left. So I end up with y squared plus y minus 2 equals 0. Factor it. I get y. I have a 2. I have a 1. I know this has to be positive. That has to be negative. That means my point of intersections occur at y equal to 1 and y equal negative 2. And I plug them in to the original equations. And which one do you want to plug it into? Because they are points of intersection. Plug it in the easier one. How about the linear one? Plug it into that one. So for my first point, when y is 1, x is 2. For my second point, when y is negative 2, put it in there, it's negative 1. Those are my 2 points of intersection. So I know I need to go between negative 1 and 2 on the x. I need to go between negative 2 and 1 on the y. Make sense? Okay, so now we're going to do our xy tables. Now that I know my points of intersection, because it's much easier to do the points of intersection that way, now I'll do everything in terms of x, and then we'll do everything in terms of y. So if I do everything in terms of x, I'm going to make an xy table. So this is going to be the y equal to x minus 1 and my xy table. So I have, and I know I got to go from negative 1. So I got negative 1, 0, 1, and 2. So I plug them into x minus 1. Negative 1 minus, so that's negative 2. Oh, that checks. That's awesome. Put in 0, it's negative 1. Put in 1, it's 0. Put in 2, it's 1. Nice. Okay, then there is the g of x equals to the square root of 3 minus x for x and y. And I plug in a negative 1 and it doesn't work. Yeah, it's imaginary. Put in 0, it's imaginary. Yeah, for this, actually I said that wrong. Negative 1? No, actually it should work. No, it's not an I. It's minus a negative. I was doing the wrong way. I was thinking it was open the other way. So I put in negative 1 and it becomes 3 minus a 1, so it's 4. And I put in a
No, it's
plus.
subtracting a negative 1.
Subtracting negative 1 is plus. Oh yeah, you're right.
Oh, yeah.
Yeah, good catch. I don't do it this way. I always do it with the sideways parabola.
It's so weird like that.
I have a hard time doing it this way. I actually just always do the sideways parabola and don't worry about it.
That one did seem easier.
It's a lot easier. That's what I wanted. That's what the point of this problem is, to show you if you do it in terms of x, it's a royal pain in the backside. But if you do it in terms of y, it's really easy peasy lemon squeezy. So let's keep doing painful. This is painful. Let's keep doing painful. Okay. Okay, that makes sense. All right. It doesn't match up to that one, does it? It doesn't. It really doesn't. So it doesn't. Those two don't intersect. Uh-oh. Really, really, they don't. Not there. Not at that point. They intersect, but somewhere else. Oh, snap. Okay. So now let's keep going. Put in 0. I got square root of 3, which is awful. I'm not gonna graph that. Put in 1. I got the square root of 2. I'm also not gonna graph that. That's a piece of junk. Put in 2. I got square root of 1, which is 1. Oh, that's a point of intersection. Look, these two intersect here. So this pair matches. So this one matches up to that one there. Because remember, it's a sideways parabola. So on the upper one, it intersects at 2, 1. So it's obviously got to intersect the other one at the other point. Right? The other arm? Makes sense now? Okay. So we're going to do the other one now. This time we have h of x equal to negative square root of 3 minus x. So x's and y's. And some of this is going to be a hot mess. Well, actually, this is fine. So it's negative 1, negative 2. Oh, look. That's at another point of intersection.
Whoa.
Whoa.
Wow.
Yeah. And then we put in 0. It doesn't work out so way. So it's negative square root of 3. We don't care about that. Doesn't help any. This is a negative square root of 2. Oh, look here. If I put in 2, it is a negative 1. Doesn't intersect, but it tells me where the point is. Right? Okay. So now we're going to graph this silly thing. Oh, yes. We're going to graph it.
At least you can do different colors on that.
I can. Different colors on what?
On your thingy, so you won't be confused.
I will. So basically, here's what I'll do is, so I'm going to graph, shall I graph the line in black?
Yes.
Yeah, so the line's going to be black.
I see black in Spanish.
Negro?
Oh, okay.
Why are you asking?
Just wondering.
Okay, I'm going to do g of x in blue,
Bro, I should probably graduate.
and I'm doing h in red. So let me get my axis set up. Oh, that's not what I wanted to do. Hang on. Is it going to let me do this? Ah, it is. There we go. I didn't mean to make this red, though. Oh, well, we'll just live with it, right? Correct? We're just going to live with it. Okay, now we're back to our pens. I'm going to graph this one, the line. The line's easy. I'm going to make my tick marks 3s. 1, 2, 3, 4. 1, 2, 3, 4. I only really need 2. 1, 2. Okay, graphing it. So on the line, the points are -1, -2, -1, -2, right there, and 0, -1, and 1, 0, and 2, 1, right? Oh, come here. So that's my line. I'm going to draw a line through it, maybe. Oh, isn't that pretty? Oops, I want to grab. Oh, that was fun. There we go. I have a line now. And now I'm going to graph g of x, which is the upper one. It's going to be the points that are actually I can graph that are nice are 3, 0 and 2, 1. So it goes up like this. Right? And actually so you go 1, I can do better than this, hang on. Being an algebra teacher, so going up 1, right 1, going up 2, it would be 1, 2, 3, 4, it should go to this point right here. Oops, would help if I had a pen. So it goes up to that one right there. So it should go like this. Right? And then for my last part, which I'm going to do in red, this is a nice point right there, and this is the other nice point. Oh, go away. Well, read your graph. What did we say?
Oh, no, sorry.
And I'm doing this based on my, me knowing parabolas. It's got to go down 1, right 1, and then, left 1, and then it's got to go down to over 4. Okay. Isn't that so cool?
Yeah, just easier way to graph it.
Yeah.
His negative sign.
Yeah. Now, I got to change the size on this because I don't like that. I don't want that big. Okay. So now, do you see that there's a problem right here? If I draw a line right here, do we have a problem?
Yeah.
Yes, we do. Here's why we have a problem. On this side, notice if I do upper minus lower, it's the blue minus the red. But if I do this, upper minus lower, is black minus red. We have a different upper and lower.
Oh, so you make 2 integrals.
Uh-huh. You do 2 integrals, you have 2 lengths.
This is going to be a 2.
And that's why the other way is so much easier. When I finish with this now, you have to know how to do this because there's going to be problems where you don't have a choice. So you need to learn the technique. But if at all possible, I'm going to show you the easier way and you're going to do it. So for this one, if I do this length right here, that length, that's length 2. And we're going to say this length is length 1. So length 1 is the upper, so this was f of x, right? And that's equal to x minus 1. This is g of x, and it is equal to the square root of 3 minus x. And this down here is h of x, and it is equal to negative square root of 3 minus x. So this length is going to be the upper, which is the line, x minus 1 minus the square root, but it's a negative, so minus a negative is plus the square root of 3 minus x. For this length, it is going to be the upper is the upper curve, so it's going to be square root of 3 minus x minus a negative means it's plus square root of 3 minus x. That means that length 2 is equal to 2 of the square root of 3 minus x. Everybody see it? Okay, so that means that if I want to find the area this way, I have to break it up into two intervals. I'm going to integrate from 0 to 2 and then from 2 to 3. So area is equal to from negative 1 to 2 of length 1, which was x minus 1 plus the square root of 3 minus x dx plus the integral from 2 to 3 of 2 square root of 3 minus x dx. Other problem with this, you have to integrate using u sub, and you have to remember that negative derivative because of the negative x. Royal pain. Would you like to see an easier way? I don't want to do that. No, yeah, okay, but this is the non-calculus section, Bubba. Okay, so remember how I said you could do this all in terms of x is equal to 3 minus y squared? What if we do this all in terms of y? That is the easier way. So easier way, I won't say everything's easy. Oh, I can't write. It's easier. Here's the easier way. Instead, we're going to do everything in terms of x is equal to y plus 1. That's my first curve. And my second one is x is equal to 3 minus y squared. We already did this to find the points of intersection, remember? Okay, so I'm just going to graph it, because with this, you should be able to just graph it. It's the same line, but it is, hang on. Make a table, make a graph. Oh good, I got black lines this time. Way more than I need, but oh well, I'm having fun with it. Okay, back to, this time I'm going to graph this one in blue, and I'll make that one red. So for the blue, it's just the line. It's the same line. Let me make tick marks for, I'm going to make them 4s. 1, 2. I'll make this a little bigger so you can see a little better. If my eyes would stop crossing. There we go. Okay, so for blue, for the line, it's that same line. So I'm going to put a line through it, but hang on, I want to color what it's supposed to be blue. Okay, good. Line. So there's our line. And now I need to graph the parabola. It is a sideways parabola. The vertex is at 3, 0. I know that if I go up 1 and right 1, that's 1 point. If I go up 2, I have to go left 3. And then if I go down 1, I go left 1. If I go down 2, I go left 1, 2, 3, 4. So it's right, oops, that point was right here. I got it off a little bit. That's okay, I can fix it. Erase that. It's okay, we're all good. The point is 1, 2, 3, 4, 1, 2, it's right there. Put the line back through. There we go. Now we're going to graph the parabola. Do I just need this part? Okay, was that a lot easier to do? For me it was. I don't know about you, but it was for me. Now, I should have done this in red. Dadnammit. Oh well, will you live if I didn't do it in red? Yeah, everybody got it? Okay, I can always go over it again in red. There we go. Erase that thing. There we go. Blue's gone. That worked ever so nicely. Okay, for this one, notice everything is solved for x and in terms of y. Before, because remember in Riemann sums, when we do upper minus lower, the width is delta x, right? So up above, right here, if you look right there, if you look that end, is that a delta x?
Yeah.
And that's why everything's in terms of x. The length is a function in terms of x, right? For this one, when we look on it, when we do cross sections, if instead of doing upper minus lower, instead we do right minus left, this time, this is my length, and it is equal to right minus left. And why do I pick right? Because I want positive numbers. Are everything to the right always more positive than the things to the left? So if I do right minus left, I always get a positive number. Well, from before, this is x equal to 3 minus y squared, and this is equal to x is equal to y plus 1. So if I do right minus left now, my length is equal to the parabola, which is 3 minus y squared, minus the line, which is going to be y minus 1. So what my length ends up being is 2, what? Yes, it is, because I forgot to distribute. I always put parentheses like this before I, no, I got it right.
Yeah, you got it right.
I had it right. I'll help you though. We'll do this the right way. I will do parentheses,
Why is it always right?
okay? And so it becomes 3 minus 2, 3 minus 1 is 2. So it becomes 2 minus y squared, right? Is that going to be a heck of a lot easier to integrate than a hot mess square roots?
Yes, ma'am.
Yeah. So this time, the area is going to equal the integral. Okay, so up above, our limits of integration were in terms of x. The function was in terms of x, and we were integrating with respect to x. What do you think is going to happen on this one? Every y. Do you see that I'm integrating from here to here, so I'm stacking rectangles in the y direction? So now I'm going to be integrating from y equals -2 to y equals 1.
Wow.
The limits integration change, the functions change, and if I look on this end, is that a delta y? So am I going to integrate with respect to, it's going to be dy.
Wow.
So I'm going to integrate from -2 to 1. The length is 2 minus y squared dy. Easy peasy, lemon squeezy. What's the antiderivative of 2?
2y.
What is the antiderivative of y? What's the antiderivative of y squared? And I'm evaluating from -2 to 1. It's not a big deal. So I do 1 first, and I get 2 minus 1/2 minus 1/3. And then it's minus, put in -2. -2 times 2 is -4. And then a -2 squared is 4 divided by 2 is 2, so it's -2. And then a -2 cubed is -8, so it's +8/3. Then I distribute the outside negative, so I get 2 plus 6, right? That's 8. Minus 1/2, minus 1/3, and then minus 8/3. That's 9/3, right? What's 9/3? What's 8 minus 3? What's 5 minus 1/2?
4.5. Wow.
Wow.
That is so cool.
Isn't that cool? It's a much easier way to do it. And that's why in Algebra 2 it's so important for y'all to do the sideways ones.
We didn't do that. I had Coach O'Deer. Yeah, he was whack.
Somebody made you do it. Huh?
I did a picture.
I know. That's because you were with me.
Didn't he tell us to just plug the logs into the calculator?
literally just said,
Yeah,
yeah,
he didn't tell us to
Ah, psh, psh. I know. Shh, shh.
He didn't do that.
Okay, hints. Here are your hints. 1, sketch them. Do you see why you have to sketch them?
Yes.
Because it can be tricky. Sketch. What do you need to pay attention to? Because it's just a sketch. It doesn't have to be perfect, but you need the point of intersection. The point of intersections need to be correct. That's how you get limits of integration. And how if you figure out if it flips and you have to do more than one limit of integration, one interval, right? You need concavity. At least in terms, you need like upper and lower and that kind of stuff. And then you may need a table in order to graph it, make it easier on yourself, right? So pay attention on the sketch. You need to practice them because you don't want to spend so much time on your sketch that you don't finish. So you don't need to graph perfectly, but you need to graph adequately to see all the features. And that just takes practice to figure out how long to spend on it, how much detail to put in it. Okay, you can't be sloppy, but you can't be ultra neat either. It's a sketch. Takes practice.
For that, when you give us the weird integral, you couldn't do that without a calculator, right? Like the square root of x minus
Yes, you
3.
can. It's u sub.
Or
What's the
is-
derivative of 3 minus x?
One.
Negative dx.
Negative.
And you do a u sub. It was done with u sub.
Oh.
Oh, you could do it, and it'd be a real pain. Okay, the next thing, after you finish, why is the graph so important? Because after you graph it, you have to decide if you want horizontal or vertical rectangles. We want to know if they make the problem easier. Okay, so you're looking at whether it's horizontal or vertical. If it's horizontal, that's the y version. In terms of y, this is the in terms of x part. And I think I forgot to write that on yours. Hang on, I need to add to this drawing. Notice everything here. When we see that delta y right there, that tells me it's in terms of y. That means limits of integration are y, the lengths are y, and you're integrating with respect to y, okay? The other one was in terms of x. So that's what happens right here is if it's horizontal cross sections, it's y, and if it's vertical, it's x. So basically, once you decide which one's easier, this one, the vertical, tells me everything's in terms of x. That means limits of integration. And the lengths, and it's dx, right? If I do horizontal cross sections, it's in terms of y, which means you've solved for x and everything's in terms of y. That means the limits of integration they're in terms of y, my lengths are in terms of y, and now I'm integrating with respect to y. And once you do that, it makes it a lot easier. So some of those problems on the area one, where they were always already solved for x, didn't you even notice some of them said x equal to? Guess what? They're easier to do in that way. They're much easier in terms of y.